Hey, Jonathan here. In this video, I'm going to go over how to generate our shiny Flex dashboards faster. Now, this video is based on a question from one of my students, Alex, who's taking my course, Our Shiny Flex Dashboards and Interactive Data Visualizations. And basically in this course, I teach students how to generate reports and interactive web applications within minutes using our Shiny and Flex dashboards. If you're new to this channel and you're keen to learn the latest tips, tricks, and tools for working more effectively with data, please hit the subscribe button for weekly videos. Now, basically what the gist of Alex's question is how come it's taking so long for him to render these dashboards after he's created them? So he has here in his note that it's taking between 3 to 4 minutes to render. Which is, like a reasonable chunk of time. Now, as a really high level overview, the things that slow things down are these right here. So data preprocessing, data loading, interactive processing, rendering graphics, and data transfer. Now, the super simplified gist of all of this is that we want to do as little of these as infrequently as possible. Now that might seem a little bit silly, but basically the gist of it is a lot of times we can end up running code a lot more times than it necessarily needs to run. And also there are other little things in there as well, but we're going to go over that. Before we get started though, I just wanted to provide a little bit of a benchmark. Now Alex has mentioned that it's taking 3 to 4 minutes to render his application. I have an application over here, and basically what this code here does is it generates a dashboard. I'm loading up a 5 million record data set, so a reasonably chunky data set into this application. And this application isn't actually optimized for speed or anything either. So it's optimized for, well, one, interpretability of the code. It also does a lot of things automatically for the user. So these things aren't necessarily things that will make it go faster, because you can add any data set to this and it will automatically pick up the columns, detect how many items are in each column, and basically populate the dashboard for you without you having to tell it anything, right? So definitely not optimized for speed, but a very handy dashboard indeed. So let's take a quick look to see how long this takes to run. So I've got a little time over here, and I'm going to click that and click the run button, right? And just while that is loading up there, I just want to show you my computer specs as well, just so you can see what I'm actually running off. So I've got a Core i7, 16 gigs of RAM. I've got a 64-bit operating system, and I also have an SSD in this computer as well. So a few things that are worth taking note of there. So this is just loading up now, and it just needs to add the plot to this as well. So around about 40 seconds or so to render around 5 million records of data. So we'll use that as our benchmark. Now that's in comparison to the 3 to 4 minutes that it's taking for Alex to run. Now let's go over some of these things here. So first up on the list is data preprocessing. Now in Alex's note, he mentions that he's got around a dozen code chunks, and each of these code chunks has around 50 to 100 lines of code. First of all, I'd say that that's actually quite a bit to be putting into in our Markdown document. Now, in our Markdown document, it can be actually used for lots of different things, right? So if you're coming from places where you're familiar with things like notebooks, you can render an R Markdown file as a notebook for doing reproducible research. And in those cases, you may be more inclined to put a little bit more code into those because you're describing all of your steps. But even in those situations, I would say that you want to start to refactor your code a bit, turn your code into functions, which is something I do actually go over throughout the course quite a bit as well. turn those into functions and then call those functions into your R markdown document instead. And by doing this, your process becomes much more interpretable. It becomes much easier to read, and your code becomes much shorter. Now, the other benefit of that is by not having the code inside the R markdown document itself, you don't actually have to render the document to run it, right? So you can have things in a regular R script, just run those and see the output. And that's going to actually speed up your process quite a bit. So when you actually come to rendering the R markdown document, it's really just for kind of presentation purposes. Now, in terms of Flexdashboards are usually either for making dynamic reports or for building web applications, right? So in this instance, you actually have again, a different kind of approach from a notebook, because maybe you're actually putting less detail into there. And what you really want to do is focus on what actually needs to be displayed for the application, basically. And so a lot of times, by the time you get to the app, you get to your report, you don't need to have all your data preparation being run like all the time. Now, let me explain that a little bit more, right? So maybe your data is only refreshed maybe once a month, maybe it's once a week, maybe, say if it's even like a day or even an hour, your data doesn't get updated all of the time, right? Unless you're maybe directly querying a database or doing streaming or something like that. So what you could do is you can actually batch a lot of the processing of your data. You can do all your joins or your cleanup, all that kind of thing, and then write that back to a file which is already processed. So you've got one script, which you can also provide the details to, right? You just don't have to run it every time. That provides all of the detail of how you processed your data. But when it loads in, it's already ready. And that saves a lot of time because it doesn't need to process when you are loading up your data. And that leads me to the second point here. So loading up the data into your application. Now, there's a few things here. So first of all, where is your data actually located? So a lot of things that I notice sometimes is that people try and load files off some intranet location on some virtual private network off a server which is actually based in another country, right? Now, effectively what's happening is that the data is having to be encrypted. It's having to go over the internet, over a slow connection. And so a lot of that time is basically just the data transfer time. So if that's part of your script that runs all the time, then that's going to slow things down. So keep an eye on things like that. Now, the other thing, though, is actually how are you loading the data? What functions are you using to load that data? Now, a lot of times in my courses, I'm loading up just say CSV files. Now, with CSV files, I'd say there's 3 key functions for loading CSV files. Now, the function that I always use in my courses is read_CSV. So that is this one here, read_CSV. Now you notice here that the first option is read.csv, right? Okay, so we've got read_CSV, and this is the one I always tend to use for my courses because this is part of the tidyverse. Now, read.csv comes with base R. Now, if you're using especially R version 3.4 or older, this is actually quite slow, right? So this actually slows down the process a lot simply by using this function. Now, they've sped it up in 3.51 and later, but I still generally don't recommend to use this library. If you're not familiar with things like the difference between character columns versus factor columns, definitely don't use this function here. Otherwise, you're going to come across a whole bunch of different issues. Now, I use this because I predominantly teach tidyverse, but a little hack is using this other function from the data tables library, so which is called fread. okay, which is short for fast read, right? Now, fread also reads CSV files, but it reads it in much, much faster than any of these other libraries. Now, a lot of times I don't really bother, I haven't really started to teach this too much yet, just because it adds an extra layer of complication. And unless you are kind of loading up millions of records of data, then you don't really need to. Just stick with read_CSV instead. But that's what I've added here to help this load in faster. So a little tip that you can use there. Okay. Okay, the next part here is the interactive processing. So when you have a Shiny application, you have something called reactivity, right? So when you interact with your application, like you change like a drop-down menu or something like that, then it goes away, it runs that logic on your Shiny server, and then brings back the results, right? And every time you do that, there is processing that needs to be done. Now, this is, to be honest, this is not really anything to do with the original render of the application itself. So if I take something like this, change it to department, this thing updates here. Now, if this part of the process is running slowly, then what you could do is basically look to run off maybe more pre-aggregated data that can speed things up, as well as basically looking into sometimes these things here. There are several updates that need to happen before you want to update the display. So what you could do is that you could effectively hold an event using event reactive function or something like that, and add, say, a little button that stops these things from firing before the screen gets updated. So little things like that can help a lot with performance. But again, as mentioned, this is more to do with the performance of the application once it's already loaded, not the initial load time. So let's go back to these other points here. So fourth point here is rendering graphics. Now, depending on what you add to your dashboard, the nice thing about these is that there's all these kind of cool controls that you can use. So here we have down the bottom a data table. Now this is a interactive JavaScript object. Up the top here, I just have a ggplot graphic, right? So there's nothing too fancy about this. A lot of my times in my course, I'm using other graphics instead, like the Viz Network library that Alex mentioned, or the Plotly libraries for doing other interactive visualizations where you've got all these different mouse overs, a bit like Tableau or something like that, where I can hover over all these points. Now, the thing to keep in mind that when you are loading some of these JavaScript libraries, they do tend to be heavier, and unlike the ggplot, which I mean, I don't have all the mouse overs, but if I did have mouse overs here with I don't know, maybe showing the different quantiles, or if I had a scatter plot where I could mouse over each of the points to reveal some of the details behind it, then all of those points, all of those data points need to be, well, rendered and sent through to the browser. So that can slow things down a bit, especially if you're providing a lot of mouse over points. So just something to keep in mind there. All right, so my fifth point here is a data transfer. Now, I think I've kind of already mentioned it in some of these other points, but let's just kind of recap on this and let me provide a little bit more detail. So in the data loading part, I mentioned, if you're transferring the data from a network or something like that, that's really going to take a long time. Now, besides, how fast the data actually transfers, there's also how much data gets transferred. And I kind of mentioned that in this kind of rendering graphics portion here and the interactive processing that, remember this particular dashboard that I've been demonstrating to you loads up 5 million records of data. If I had to get that 5 million records of data and send it through to the actual application, to the actual, whether it's a notebook or a Flex dashboard or whatever it is, that's going to take a really, really, really long time. It might even crash the system because that's just too much data to be held inside an actual dashboard. The reason why that this works is because that the data is loaded. It sits inside the R server inside an R object. And it's only the aggregation of that data which is actually sent through to the dashboard. And that's what makes it sort of relatively fast, right? So something to keep in mind there. Anyway, I hope that these tips have given you some ideas of how you can speed things up, make it go faster. I hope this helps. Thanks for watching, and I'll see you next time.